Hello, space enthusiasts, and welcome back to our channel. Ever look up at the sky and wonder, could our sun just explode? It's a question that sounds like it's straight out of a sci-fi movie, but it touches on some of the most fundamental processes in our universe. Today, we're going on an epic journey through time, spanning billions of years, to uncover the true fate of our star. Will it end with a cataclysmic bang, a supernova that lights up the galaxy? Or is something else entirely in store for our solar system? The answer is more fascinating than you might think. So buckle up as we explore the life, death, and incredible transformation of the sun. Right now, our sun is in the prime of its life. Think of it as a middle-aged, stable, and predictable star. It's classified as a yellow dwarf, and it's been shining steadily for about 4.6 billion years. What's powering this celestial engine? A process called nuclear fusion. Deep within its core, where temperatures reach a staggering 15 million degrees Celsius and the pressure is immense, the sun is fusing hydrogen atoms into helium. This process releases a tremendous amount of energy, which radiates outward, providing the light and heat that make life on Earth possible. This phase of a star's life is called the main sequence, and it's the longest and most stable period. Our sun is about halfway through its main sequence stage. It has enough hydrogen fuel in its core to keep burning like this for another 5 billion years or so. So, for the foreseeable future, and we're talking a really, really long time, the sun will remain the reliable, life-giving star we know and love. There's no imminent threat of it suddenly changing or going dark. It's a massive, self-regulating nuclear reactor, maintaining a delicate balance between the inward pull of gravity and the outward push of the energy from fusion. But what happens when the fuel starts to run low? This is where the sun's story takes a dramatic turn. In about 5 billion years, the hydrogen in the sun's core will be depleted. With the fusion engine in the core sputtering out, the delicate balance that has defined the sun for billions of years will be broken. Gravity, which has been constantly trying to crush the star, will begin to win. The core will start to contract and heat up even more under this immense pressure. This increasing temperature in the core will be so intense that it will ignite a shell of hydrogen that surrounds the core, a layer that hadn't been hot enough to fuse before. This new, ferocious burst of energy from the hydrogen shell burning will push the sun's outer layers outward, causing the star to expand dramatically. This is the beginning of the sun's transformation into a red giant. When the sun becomes a red giant, it will be a truly awe-inspiring and terrifying sight. Its size will swell to be hundreds of times larger than it is today. Its expanding outer layers will engulf the inner planets of our solar system. Mercury will be the first to go, followed by Venus. Earth's fate hangs in the balance. Some models predict our planet will be swallowed by the expanding sun, while others suggest that as the sun expands, it also loses mass, which could cause Earth's orbit to widen just enough to escape being consumed. However, even if Earth isn't physically engulfed, the intense heat from the bloated sun would have long since boiled away our oceans and scorched the surface, making our planet completely uninhabitable. Despite its massive size, the surface of the red giant will actually be cooler than our sun's surface today, which is why it will glow with a reddish-orange hue. But don't let the cooler temperature fool you. It will be a colossal fiery furnace dominating the sky. This phase will last for a few 100 million years. It's a slow, majestic, and destructive expansion, but it's important to note it's not an explosion. It's a gradual, albeit dramatic, change in the star's structure. So why doesn't our sun explode? The key lies in its mass. The most spectacular stellar deaths, the supernova, are reserved for stars that are much more massive than our sun, at least 8 times more massive, to be precise. In these giant stars, the fusion process doesn't stop with hydrogen and helium. Their immense core pressure and temperature allow them to fuse heavier and heavier elements all the way up to iron. Iron is a sort of cosmic dead end for fusion. Fusing iron doesn't release energy, it actually consumes it. So when the core of a massive star becomes filled with iron, its energy source is cut off completely and catastrophically. Gravity takes over in an instant, causing the core to collapse in a fraction of a second. This collapse triggers a violent rebound, an unimaginably powerful shockwave that blasts the star's outer layers into space. That is a supernova, an event so bright it can outshine an entire galaxy for a short time. Our sun simply isn't massive enough to create the conditions needed for this kind of catastrophic collapse. It doesn't have enough gravitational force to fuse elements all the way to iron. Its journey is a bit more graceful, less explosive. It will swell up into a red giant, but it won't detonate, so what happens after the red giant phase? After a few million years as a red giant, the Sun's core will have become hot enough to begin a new phase of fusion, turning helium into carbon and oxygen. This provides a new, temporary energy source that causes the Sun to shrink a bit and stabilize for a while. But the helium fuel will also run out, much faster than the hydrogen did. Once the helium is gone, the Sun enters its final stages. The hydrogen and helium shell burning will become unstable, causing the Sun to pulsate. With each pulse, it will shed its outer layers, puffing them away into space. These expelled layers of gas will form a beautiful, glowing structure known as a planetary nebula. These are some of the most stunning objects we can observe in the cosmos, like cosmic smoke rings lit up by the dying star at their center. It's the Sun's final, beautiful goodbye to the galaxy. And what about the core that's left behind? After shedding its outer atmosphere, all that will remain of our once mighty Sun is its hot, dense core. This remnant is called a white dwarf. It will be incredibly dense, a mass comparable to the Sun's, packed into a volume about the size of Earth. A single teaspoon of a white dwarf would weigh several tons. This white dwarf will no longer be generating any new energy through fusion. It will simply be a celestial ember, glowing brightly with leftover heat. It will start out incredibly hot with a whitish blue glow and then, over an almost unimaginable timescale, trillions of years, far longer than the current age of the universe, it will slowly cool down and fade away. Eventually, it will become a cold, dark object, known as a black dwarf, a dead star drifting silently through the cosmic darkness. So, to answer our initial question, no, the Sun will not explode. Its fate is not a violent supernova, but a long, slow, and transformative journey. It will swell into a red giant, shed its outer layers to create a stunning planetary nebula, and finally, settle down for an eternal retirement as a quiet white dwarf. It's a humbling perspective, isn't it? The life cycle of our star unfolds on a timeline so vast it's difficult to comprehend. We are living in a perfect, stable moment in its long existence. While the end of the Sun does mean the end of our solar system as we know it, it's not something we need to worry about. We have a good 5 billion years left to explore the universe, learn its secrets, and perhaps even find a new home among the stars. The universe is full of these incredible stories of creation, transformation, and endings that are just as fascinating as beginnings. Understanding the fate of our own Sun helps us appreciate our place in the cosmos and the intricate laws that govern everything from the smallest atoms to the largest stars. Thank you so much for joining me on this journey through the future of our Sun. I hope you found it as mind-blowing as I do. If you enjoyed this video and want to explore more cosmic mysteries with us, please hit that like button and be sure to subscribe and turn on notifications so you don't miss our next adventure. Until next time, keep looking up.